Now let's enter our BIOS and configure the system with the appropriate time. So we'll set our time to GMT or UTC, Universal Coordinate Time, time coordinate, which currently is 4 hours ahead, so this should be 1534. And the date looks correct. So with that said, let's exit. Now the reason why we're doing that is to ensure that the offset that's set by the operating system is correct. Usually your servers, or virtual instances in this case, should be set to GMT or UTC and then offset by the operating system during boot, which will ensure that the operating system is able to set the correct time regardless of daylight savings time configuration for your time zone. So again, ideally, configure your BIOSes to be set to GMT. So let's go ahead and save the changes, and then this will boot to the appropriate ISO image, which will start the 64-bit installation. Now here's the main menu. We'll press space, otherwise within 10 seconds the installation will begin, which will be less than ideal. So what does the main menu provide us with? Some sensible options, of course. We can boot the FreeBSD installation, which is the default options, or disable ACPI, or boot in safe mode in the event that there's hardware preventing us from booting the system. We may also boot into single user mode using the ISO image or the CD-ROM that's made from the ISO image to recover a system or to perhaps troubleshoot, or perhaps just enter single user mode for the sake of backing up or doing something exclusive on the system that other users should not have access to. When FreeBSD is up and running, it's in networked mode, which means it's in multi-user mode, which means other users are likely to be connected to it using one or more protocols such as SSH, XDCMP, etc. So you can also boot FreeBSD with verbose logging, which enables much more useful information in the event that you're experiencing some sort of boot error related to hardware. Let's say, for example, a faulty graphics adapter or problems with memory or otherwise. So let's go ahead and boot the installation. And that's option 1. Just like with Linux, it detects hardware. And momentarily we'll have sysinstall. Now this is the main sysinstall interface. It's similar to many Linux installation interfaces. Notice it defaults to the United States, so we'll select this. But for your country, do otherwise. And then we're presented with the AMD 64 8.2 release installation menu. Now, there are a number of options that are available. For example, the standard installation, which will auto layout your disk and install sensible packages. The express installation, which allows us to make changes that standard does not. The custom installation, which allows us full control of the installation, including all partitioning and otherwise. And many other options surrounding post-installation. For example, the configure option allows us to make network changes. Documentation, the key map for the keyboard type, and a few other sensible items. The key options that are of interest when installing a new BSD system are standard, express, and custom. If you're very familiar with FreeBSD, go ahead with custom, because that way it'll allow you to fully detail the installation, packages, partitioning, etc. Otherwise, you have some options to make between standard, express. Let's go ahead with standard, which is the recommended installation. Now notice, it tells us in the next menu we'll need to set up a DOS-style partitioning scheme for the hard disks. So that means for one or more hard disks that are configured, we need to lay out the appropriate slices and partitions that are required for the operating system. So let's go ahead and press OK. Now here's the unused space represented by its total number of sectors. Now sectors, as we can see, there are over 16 million, represent 512 bytes of data. So if you divide the number of sectors by those 512 bytes, you'll come up with roughly 8 gigs. So we have storage of about 8 gigabytes represented using the sector notation. So when you lay out partitions or slices initially and then partitions within slices, you're concerned with sector allocation. Now the disk geometry varies across various systems. So you'll need to pay attention to the geometry for your hard disk or disks in order to make sensible decisions. But for this disk, it's rather straightforward. There's 8 gigs available, represented by roughly 16.7 million sectors. Now, if we'd like to use the entire disk, the A option is available. So simple A will use the entire disk. Let's go ahead and select that option. Lower or upper will work. Now notice the allocation of storage. 2 slices, which are of negligible sizes at the beginning and the end of the disk for legacy reasons, are reserved. The bulk of the disk from sector 63 through 16,771,797 become available for us to lay out the FreeBSD partitions. Now, the notion of partitioning with FreeBSD slightly differs from other Linux-based systems in that it's more traditional Unix, in that you need to lay out slices first, then partitions within slices. Also notice above the disk name as DA0. Any disk within the FreeBSD environment that's prefixed DA is a SCSI disk. It may also be a SATA disk, which is much more ubiquitous nowadays. So SATA or SCSI disks are denoted with a DA prefix. The first SATA or SCSI disk is labeled DA0, and its geometry follows. So this is what the automatic usage of the entire disk will do. Now, if we agree to these changes and we need not lay out additional slices, for example, we simply select Q to finish. If you'd like to make changes, you can delete an existing slice and then create your own slices. But we'll do that in a subsequent installation. So it's Q to finish, and that returns us to the sysinstall screen, which asks us about the boot manager. Now, we've mentioned that there are a number of boot manager options available, 3 for that matter. They include standard, which has a non-interactive boot manager, which means after the BIOS hands off control to the operating system, it doesn't present the user with the ability to interact with the boot manager. It simply boots the operating system right away. That's a standard option. The boot manager option installs the FreeBSD boot manager, which allows us, among other things, to boot other operating systems as well as enter various modes such as single user mode. And then the none option. This is ideal if you're dual booting or if you're triple booting or otherwise. If there is another boot manager that is available on the system to boot FreeBSD, use the none option. So let's go ahead with the boot manager option, which installs a FreeBSD boot manager. Now that we have a slice defined, which is roughly the majority of the 8 gigs, we need to create BSD partitions within that particular slice. So again, the hierarchy within FreeBSD is you have a hard disk with a certain geometry within which you lay out one or more slices, within which you lay out one or more partitions, which of course are then overlaid with the Unix file system version 1 or 2. So let's go ahead and press OK. Now, notice we see no mount points, no partitions, no nothing to give us a sense as to what the installer would like to do. So how do we move forward with creating the various partitions that are of interest to us? Well, we can just C to create, and this will ask us how large we should make the particular partition. By default, we can go with the entire sector space, which is 16.7 million or so, and that'll be allocated to one partition. That's usually not a good option because that means we're not able to segregate the various partitions. If you'd like to see a suggestion provided by FreeBSD, select the auto option, which is A, and notice all of a sudden we have a proposal for partitions that will be made within that main slice. Now let's take a look at the notation. If you notice above, we see, for example, for the first partition, DA0 S1A, followed by B, D, E, and F. Now, partitions within FreeBSD are labeled A through H, with B being reserved for swap. So notice the first partition, DA0, which is the first SCSI or SATA disk, the first slice, slice 1, the first partition A. So that's how it's to be read. First SCSI or SATA disk, DA0, the first slice, S1, and the first partition A. Again, partitions are labeled A through H. And it is for the mount point root, which the proposal suggests to be formatted with UFS version 2, and that it is to be roughly 716 megabytes. That's a proposal. Followed by the second partition, B, which is on the same slice, on the same disk, slice 1, disk 1, or the first disk, which is indexed at 0. Notice the slice is indexed at 1. because there is a smaller slice already defined. If you recall, when we told fdisk to define slices, it created three. A first small slice for legacy purposes, the main slice, which is slice 1, and a small slice at the end of the disk, slice 2. So we're really using the second slice, which is slice 1, but for our intents and purposes, we call it the first slice. Remember, most of these enumerations are indexed at 0. So the swap partition is going to be 432 megs. Now, that isn't standard twice to 3 times random access memory, but it'll suffice for our configuration because we'll provide additional swap storage later on via additional storage means. Notice var is indicated as just under 2 gigabytes, UFS 2 as well, and temp is 486, just under 500 megs, and user, where applications are installed, will occupy the bulk of the disk, 4.6 gigabytes. If this proposal is acceptable, you can continue and move forward with the installation. Now, it's important to note that at this stage, no partition changes have taken effect on the disk. Very important to note, because oftentimes administrators are worried at which point partitions are committed. Normally, across most operating systems, partitions are committed just before the software installation process begins, meaning the copying of the various software items. So these proposals are just that until we are ready to commit the changes. Now notice the undo option, that's U. If you select that, it undoes, or it undoes, that is, the proposed layout, which has not been committed. So it hasn't been done yet, but the undo simply means undo the presentation of the proposal. But we can recreate using the entire disk. So again, here we are. This is back to the original configuration. We haven't laid out a slice. If we use the entire disk, it creates the following slices, 3 slices, with the middle one being the first usable. And then we go ahead and finish. Tell it, notice it loops us through this option again. Install the FreeBSD boot manager, and now we need some partitions. Now again, you can lay out your partitions manually if you'd like. You can toggle status, UFS1, UFS2, etc. And you can lay them out precisely as you see fit. But we'll do that in a custom installation. Let's go ahead with the auto defaults and elect to commit to these changes to see how rapidly the operating system will install. Now, when you're completed with each of the fdisk stages, just execute Q to finish, and then it moves on. So now we have options to specify the CAN distributions or packaging options included with FreeBSD. A sensible option is to select all for all of the various ports included with FreeBSD. So it asks us if we'd like to install all of the FreeBSD ports. We'll tell it yes. So we'll tell it all. And these options here include, when we select all, developer code, kernel developer code, user code, and so on. But there are other options such as minimal and custom. Custom will allow us to specify, of course, explicitly the components of FreeBSD that are installed. The footprint of FreeBSD is very small, so selecting all will work just well. Now to select it, we spacebar or press enter and then navigate to OK to continue with the options. Now notice when we selected all, it told us that there were roughly 19,000 plus ports available. It's currently over 22,000 at this stage. Now we have to indicate to FreeBSD where to find the various sources. Since we're using an ISO image mounted through VMware, we'll simply elect CD/DVD. However, if installing across the wire, perhaps off of an internal or external server, use FTP or FTP passive or HTTP or NFS. These are the networking options available. But notice the other options, such as installation from a file system, such as an existing UFS file system, UFS1, UFS2, from a DOS partition that may exist on a disk that contains the FreeBSD code, from n number of floppies, from a USB stick. FTP and FTP passive simply specify the differences between traditional FTP port-based mode and passive mode. Passive mode is firewall friendly. So let's go ahead and select CD/DVD. Now at this stage, we will end up committing the partition changes to the disk after we press enter to select yes, and then the appropriate FreeBSD operating system code will be copied, and then we will have our system ready to be booted, but then of course post-installation configuration needs to take place. So let's go ahead and tell it yes, and now the partitions have been written, and now the base code of the operating system is being extracted into the root. The base is represented by the base directory within the CD-ROM that you've obtained for your platform. It is the required component of the operating system. Everything else is ancillary. So this is pulling in various documentation, as we can see, for various languages. And the files that are on the CD-ROM or within the ISO image are compressed. As we can see, TBZ, so tar and bzip version 2 compression. So they have to be extracted as well as decompressed before they're copied to the hard drive. Sometimes it takes a while for the files to be installed on the hard disk because there are thousands of files included with the FreeBSD installation. Thousands of small files, and it simply generates a lot of I/O activity, which results in a longer installation time. But compared to many other operating systems such as Linux, Windows, etc., FreeBSD wears the smallest footprint, except of course for the slimmed down versions of any of those operating systems. But it's rather a low overhead operating system, at least at the outset. And then as you install other packages, then it gains a larger footprint or some more weight. Now during installation, as mentioned, various consoles are available via Control-Alt or Alt-F1 as well as Alt-F2. And that's Alt-F1, which dumps to the screen any errors as well as successes. And then Alt F2 also shows useful information. Alt F1 takes us back to the main console. And Alt F2 shows us this dump. So it shows the packages. Bind9, for example, was recently dumped. And it was unable to find ldconfig at the time. You also get a sense of the transfer rate in the lower right-hand corner. As we can see so far, the extraction rates have been on the order of roughly multiple megabytes per second. Again, if you scan the ISO image or the CD-ROM you've created or DVD that you've created for your platform, you'll see these TBC files from the various directories that are being extracted. Many of the applications that you install, by the way, are pulled across the net when installed using the package add facility. There's an index of the latest ports available on your local system if you install the ports packages, so it knows what applications are out there, but then at install time it will, and that is FreeBSD, pull the appropriate code in from the net, unless you've set up a different FTP repository, let's say internally via your intranet. So this is moving along nicely, and we should be up momentarily. Let's take a look at Alt F2 to see what's going on. So currently this is GCC related code. We selected all, so it's including, of course, compilation tools. This gives us a clear sense of the exact files that are being copied at any particular point, because the main sysinstall interface just gives us a summary, so it's not as specific. There are some sbin items, share items, etc. So it's just a wholesale dump of the requisite code to run FreeBSD. Again, this is a standard installation which supplies prepackaged items as well as sensible layouts for your partitions. Using this as a template, we're then able to perform more intelligent custom installations for our application. You'll find that your installations vary depending on the purpose of the server. So sometimes, for example, for logging servers running syslog, you'll need large dedicated var partitions, perhaps on distinct disks for performance reasons, versus general purpose servers that don't do as much logging. So your mileage will vary depending on the configuration and available hardware resources. But depending on the configuration of the server will determine how you lay out your partitions. And that's really the key difference. Of course, the application's footprint is rather small, so the key difference across installation types tend to be partitioning, the layout of the partitions. Just a general note on partitions, regardless of operating system, it's always sensible when installing a NIX-based system to spread out your data across multiple partitions, especially the key mount points, such as the one that's extracting currently user/user, which contains applications, documentation, etc., as well as var for changing data, syslog information comes to mind, as well as home for your user data, so for users who connect via means such as SSH, VNC, FTP, even perhaps via HTTP. Then for those users, you should have a distinct home. So home, var, user. The root file system should be distinct, need not be large, but distinct, so that the key items that are necessary for booting the system are held separately. And that items that fill, let's say, other partitions such as var do not wreak havoc on partitions such as root, which will prevent the system from booting. So now we're being congratulated that the system has been installed. Now, for example, if we'd like to make configuration changes to the installation, post-installation, once the system's up and running, and we're at the console or we've SSH'd in, you can simply run sysinstall via user sbin. If you're logged in as root, user sbin is in your path. If you're not, it should not be. However, sysinstall will just bring the installer back up and give us the option to perform post-installation configuration. So again, enter a space will allow us to proceed at this point. So let's go ahead. Now it asks us if we'd like to configure any Ethernet network devices. This is critical, absolutely critical, because otherwise we won't be on the net. Now, unlike Linux, which uses ETH followed by a numerical value 0 through N, FreeBSD uses E followed by M. So EM and a numerical value indexed at 0. So it detects, in this case, a Pro 1000 or Pro Gigabit Ethernet card, as well as a parallel port interface, which is, of course, not of interest in this particular case. Nonetheless, let's go ahead and configure EM0. IPv6 will turn it on because we always come up with things to do concerning IPv6, basic communications, and we'll tell it not to go with DHCP. If it does, it'll simply derive an IPv4 address from the appropriate DHCP server on the wire, which happens to be the Cisco router. Now let's go ahead and just name the host UnixCBT1, UnixCBT internal, which will copy the name over to the domain field with a default gateway of the following, and a name server of the following, and an IP address of the following, 40. UnixCBT2, the box that we reviewed the features of FreeBSD on, has an address of .50, so we'll index this system at .40. The net mask is /24 or 24 bits, 255, 8 bits, 16 bits, 24 bits. And if there are any options that are necessary to work this interface that ifconfig should know about, this is just a form for ifconfig options. So if there are any special options that need to be passed into your network card to make it, let's say, perform better, or let's say deliver larger packets by default, then this is the field to specify those options. For standard Ethernet interfaces, options are not required, but in some environments, let's say jumbo frames, those options may need to be enabled. Let's go ahead and press enter. And it asks us if we'd like to bring the interface up. And do you want it to function as a gateway, which is basically a router? We'll tell it no. And do you want to configure INetD at this stage? We'll tell it no. We can configure that later. SSH will enable so we can connect across the wire. And we'll tell it no for FTP access, as well as NFS client and server access. And it asks us if we'd like to customize the system console settings, such as the font, the key map, the screen map, the TTYs. If you choose TTYs, you can tell it which terminals you're running. We'll just tell it don't touch anything. Just wanted to show you the options that are available. And let's cancel this by exiting, which will take us to the previous menu. Now let's set the time zone. Now, is this machine's BIOS clock set to UTC? It is. That means we need to set the offset, which is, of course, within the Americas, and it's the United States. we can just page down through this list, or just type U to go to the index for U. So if you're above it, just type it, and it brings you down. And that sets us to Eastern Time, which is the proper offset. EDT is currently the appropriate offset. And it asks us if it has a PS2 serial or bus mouse. It actually has a USB mouse. We'll show you the hook for getting that to work with X. We'll tell it no, those mice are not available. And it tells us the package collection has a number of packages. So if we'd like to browse it now, we can. And to mark a package, we just move to it and press space. And here are the various packages across various languages that are available. They're all checked because we selected everything in the prior section. Tell it no, we don't want to actually delete any items. So let's go ahead and install these items. No packages. They've already been extracted. So let's set up the initial account. So that was just a glitch because it didn't recognize initially that the packages were already installed. Now, just like with any other OS, such as Linux, you're prompted to install a default account that is non-root. So we navigate to add a new user to the system. You may also define a new group if you'd like. And we'll call this user UCBT. Notice that the user is indexed one above 1000 at 1001. Let's set a password for the user. And we'll just call the user UCBT user. Currently no memberships. We'll do that all manually. Now the default shell, as we've mentioned, is C shell. We'll change this user's shell to bash once we're up and running and have confirmed that bash is installed. The default directory is beneath /home, just as it's the case with Linux. If you'd like to define a group, perhaps for sharing files, directories, etc., that option's available. We'll just cancel because we're not prepared to do that at this stage, and then exit. So now you need to set root's password. That's a system manager. Let's go ahead and press OK. And at the prompt, it asks us for root's password. That ensures that root must enter a password. So if we'd like to visit the general configuration menu for any options, we say yes. That's back to the sysinstall menu. And if we're done, we can tell it to exit the installation. And we'll tell it to reboot. This will quickly get us back to a running system without or sans a GUI. It also tells us to be sure that the media happens to be removed from the drive. Otherwise, it will boot from that particular ISO image or CD-ROM or DVD. And now we're booting up from the hard disk. And that's just as simple with VMware as disabling the boot CD-ROM. And if we wait momentarily, we'll see that it boots. And here is the menu. If we select no option, it simply boots FreeBSD. But again, there are options such as single user mode. So let's wait for it to boot. And just like with Linux, this will have the kernel load to detect the hardware available on the system. Just like Linux, FreeBSD supports DevFS as well, so it automatically detects devices and creates the nodes for those devices on the fly in the dev tree. And above we see the IP address for 7540. The appropriate SSH key was generated, and now we're ready to log into the system. Notice the FQDN of the host, UCBT1, UCBT.internal on TTY v0. So let's go ahead and log in. And now we're on the system. Let's take a look. It mentions the security handbook helps us out with documentation. DF-H shows the partition layout. And as we can see, the first SCSI or SATA disk, and this is the first slice. And it's the first partition A for the root file system, of which 273 megs are used. DevFS for automatic device detection. And we see the other ones, D, E, and F. As we've mentioned, B is reserved for swap. So this system's up and running. From the user file system, we can see that 3.6 gigs have been used for applications. Just like with Linux, if we execute ifconfig, the same utility, it will enumerate the appropriate IPv4 and v6 and layer 2 information, as well as options that are supported for the interface. So for example, here's the layer 2 information, the MAC address for this network interface, EM0, and its INET or IPv4 address of .40, its appropriate broadcasts, its link local INET 6 address FE80, its 6-to-4 address 2002, which is routable, the status of the interface, gigabit full duplex, the loopback interface, the PLIP interface, which we're not using. So that means, of course, if we send a few packets, let's say to the default gateway at .1, it should respond. And that means it is up and running, as well as for any other system on the wire. We're logged in as root. If we echo the shell, you'll see that it defaults to C shell. The bash shell, for those of you who are familiar with and comfortable with bash, is usually located beneath user local bin. If it's not, you can always install it, but we'll look at that. That's the non-issue. You can do a find user name bash to have it search a tree. And it should not be installed by default, but that can be installed momentarily. That's not a big deal. So we're using C shell, which means it's not as forgiving as this particular item. Notice in the user ports, let's go to user ports shells bash and pwd. So this is the directory. So if we did a make here, it would install bash, but nonetheless, we're in full business. So let's log out and proceed with another installation.